Hello everyone, welcome to my channel. I am going to continue the Rockwell Studio 5000 Logix Designer as part 2. In this video, we will see how to make the basic programming in ladder logic and how to create the subroutines, tasks in Studio 5000. And we will see how to create the user defined data types, that is UDT, and apply in the program. Let's start now. Open our previous application which we used in part 1. So we will continue with the same application. Just I will double click the controller tags. See, we created already in the first part, we created the tags. So, and also we created the hardware configurations as well as the tags as controller tags, and we will start now with the remaining part. See, in this controller tags, if you open the controller tags, you can see all the tags which it's created directly after you created your IOs, this local tags. And I created these two tags, pump auto and pump run. Now again we will create some tags. Before that, just I will introduce you how to see here the parameters and local tags where we created the tags, and also in the main routine we added one small logic before to know that how we are going to make the main program. Close all the tabs. Now we are going to create a new program. Before that, we will see the main routine properties. Just right click the main routine in the properties. You can find the type in program and number of runs. Just cancel and go to the main program. Right click the main program. In the properties, you can find general, configuration, parameter and monitor. If you go for the configurator, you can find which routines you need to assign. See, I already mentioned that main routine. So I already added the main routine. If you have some other logics, you can add here directly to the main program. So that one will open as first. If you see in the Siemens, you have OB1. Similar to this, you can assign directly here the main program in this main program task. So if I see, I am going to add new main program. So I just go there, add new routine and give the name. Just I will add now for testing purpose. I will give this one as first program. If you see downside, you can find the types ladder logic, sequential flowchart, functional block diagram and structure test. So I will use as default, and then the program or phase I can use the main program. And if you need to assignment, you can give none or fault, and I can just give create OK, and it's added a new program called first program. In this tab, we are going to create the ladder logic. As default, the screen will open in the first run line, and if you go to the favorite tab, you can find runs, branch level, normally open, normally close, and also it consists of coils, latch and unlatch coils as well. As usual, the run will start from the left side to the right side and starting from up to down. If you need to know more about the basic ladder program, follow the previous video so you can understand better idea about the basic concepts, about the NO, NC and OR concepts. This will take only 5 minutes to understand. Before moving to the program, first I will explain what is the main task and subroutine and what are the tasks we can create. Right click the task. See, you can find here new task. If you right click the new task, then it will open a new task page. Here you have to create example. I am creating, this is my first task. So I will create first task, and here you see here you have option periodic or event. When that task will run the application, either it is periodic or it should be by any event. Example, if you have some alarm, it will create your new task. See, this one I create now periodic. If you see in the periodic task, I can create a new program as well. In this program, you can create example same like the main program. you can give this one as subroutines or sub programs. See, I will give sample, and here you can interlink this one with main program. And if you see when it should be start, it is in the schedule in first task. So this program will schedule in the first task, and even you can see normally fault handler, first task, main task, power up handler. So you can give any of the options. See, it's created in the this task will created in first task with sub program. If you see our main task, it is separated, and the first task it is separated. So you can make many subroutines or subtasks. From this one, you can create either by event or by periodic. Event means if there is something happen, you can start this logic. Example, I need to run this logic after this pump started. Then it will start this subroutine logic. So I can create this one easily. Similarly, you can create many tasks. See, now I am going to create another one task called task 2. And even I can give the timing here. See, I am going to change the timing. This is 20 millisecond. Once I give, see, it is started, it's given, the first task will start in 10 millisecond and the second task will start at 20 millisecond. But in the main task, it started in between. Because the main task, it is continuous, and it is the watchdog time, it is having 500 millisecond. And this main task, it will start between 10 to 20 millisecond. See, you can see here, periodic, it's 10 millisecond. So I will give 5. If I given 5, see, this main task become, now before it is working in periodic, see, and before it's work with continuous, sorry. Now I am changed to periodic. And even you can change to event. For the main task, you have 3 options, either continuous, periodic, or sub events. So I will see, now I will change all these 3 in periodic. So just remember, the main task, it will be work in continuous as well. But the other tasks, you cannot do that one because you are giving by periodic or by event. Now we will come to our main program. Just I will open the main program, and I am going to add now the new logic to understand how to create the new program. So just I will click here, normally open contacts. Once you click in the rung itself, it will be add automatically. Even no need to drag and drop here. See, here it will come directly. And where you keep your cursor, if you click, it will be automatically added next to the cursor. So it is very easy to understand how to add this ladder logic. And also see here, I can drag and drop the ladder logic. Normally like the simple like operators, this means operands. This normally open, normally close, or any coil or contact, you can just drag and drop in the rung. It will directly insert. So if you need to add one more, see here, branch or sub branch, you can add directly. Just click your cursor and add directly. But it will for this RS logic or Logix Studio 5000, it will take little compared to the other programming part. It will be little bit tricky because you need to understand how to add. See here, this branch, sub branch. So it will at first time it will take some time. But after if you've practiced, it is very easy to add. See, now I already added normally open contacts and normally close contacts. Now I am going to link the address tags. See here, I already have that some tags which we created earlier. And see this, I am going to add this any of the signal now. Example, pump 1 or 2. Just double click and you can browse the tags. You can find all the tags which is created in the controller tags as well as parameter and local tags. So just I am going to add some any one of the tag here, and even if you go, you can add some physical hardware tags as well. Even if you type, it will automatically detect. It will browse from the tag list and it will show to you here. See here. So I can browse as well, and I can add the signal. If I add some of the signal, if I create a new tag, example, I'm adding now, see this pump start command. I'm just planning to add one signal. See, it's come, I already added, but it will be really, it will work or not. Just we will see now. See, just I added before that, I will add some other signal, pump command, and I will browse the signal here, pump command as well. And if you see here, normally open contact, I can add one more signal. Just I will add anything here, no issue. I will add pump status. And here I will create one more tag similar to the pump start SCADA. Just I will create PUMP_trip. See, now I created, but it is not defined, it is undefined tags. Pump trip and pump start SCADA, it is undefined tags. If I browse, if I make compile, I did not find error, but if you see here, you can see everything is in red color. See, it is in the arrow mark. Here it's in the left side of the rung. It is showing X, red color X. This means it is not correct. There is something wrong. So how I can troubleshoot these things? So first of all, you need to understand, you cannot create directly. See, you cannot define directly to this run, to these tags. So either you have to define the new tag by directly from there itself, or first you have to create in the controller tag and in the parameters and local tag. Otherwise it will come to you this error. See, it is undefined tag. So I need to be right click. First I will delete this instruction. Add ladder element. This one also you can change your normally open or close contact directly from this place. See, you can change anything what you need here. Normally open or bit or input, compare, alarms, MOV, move or anything. If you need to change the instructions, ladder element, you can change directly from here itself. But in our case, just I need to change this tag name only. So just I will first, I cannot able to link this one to the controller tags. So what I need to do, first of all, I need to remove the tag and I will create again. But if you see in the others like Schneider Unity Pro or Siemens TIA, you can create directly, you can define here directly, and it will define directly to the controller tags or in the parameter or local tags directly, correct? So now in Studio 5000, you cannot do this one directly. So I need to be, these two tags I need to be removed from the tag. See, I will add again, sorry. See, I will add again. If I right click, I can find new tag. From there, I need to create a new tag. Once I create the new tag, example pump underscore trip. See, now it's automatically default, it's come boolean main program and it is created automatically. See here, because the main thing, if you are doing directly data entry here like tag entry, it does not know where it need to be stored, either in the control tag or the parameter on the local tag. So you have to make a right click, new parameter and define from there only. Otherwise, you have to create earlier in the parameter and local tags or in the controller tags. You have to create first. So there is two options. See, now there is no error. See, now the error gone, and you can it is okay now, because if it's having any error, you can find in the rung in red color. Okay, now we will go for the next step where I can add that rung. So if you see in this line, you don't have anything option, like here only we have wrap text and everything. See here you can find the rung. So just double click there, it will be automatically create a rung. See, and if you go for normally open or normally close, you can add directly from here. and I just showed now how to add the normally open, normally close contacts, and also I will show you some other instructions like how we can add directly here. Example for timers, counters like this. See, you have lot of option here. This is all digital alarm, analog alarm, and also some alarm set operations. So we have lot of instructions here. Directly it is embedded. So you can utilize any one of them as per your logic. So this is the beauty of Rockwell programming, because in the Logix Designer or Studio 5000 or anything, you can find you have lot of instructions available inside. So you can use directly from there itself. See, if you see a timer, you have that on timer, off timer. It is, see, you can, now I am going to add the timer now, and you can understand more about the instructions as well. See, now I will take this directly to the on timer, and I will create, first I will define here the tags for the normally close. See here, just I will give the pump command for this normally open contact. And here, see, in that on timer, this is TON, means on timer. It's mentioned timer preset accumulate. What I can add here? See here, I did not find anything, and it's mentioned only sample data types usage, and this is the things only you can find here. Then how I can add this run? See here, sorry, this TON, and I need to give here timer millisecond, or it is seconds or milliseconds or whatever you need the on timer. You have to define the time here. See, if I enter directly in the timer TOS 60, still it is having error. See, in the run you can find this error still persists. It's not removed. So this means there is something wrong. How I can make this one? See here, if I click here, I can change only the elements only. That is the instructions or element I can change directly from here. Timer, on timer or off timer or anything. Okay, but from this timer inside, what I given now until I am missing some part. Just think what I missed that one here exactly. So if you see here you can change only the elements. If I click that timer on, see, I try to change something here in the timer. Just I am trying to give something name here. Even you can enter anything, but the error will not persist because it will continue. The error will continue. See, there is something problem. So where is how I can remove these things? If you have any doubt, just press this timer and enter F1. It will open the help directly. Okay, so I will show you again that one later. See, now in our case I need to change this one, this timer. See, it is undefined tag. This means the timer is tag. So you have to double click the tag and it will open this one. See here, this is the name, timer 1. Okay, and I will enter the see, data type is timer. Once I created, then only it is, see, it is visible now, and it's the error also is gone. So you have to define first the timer. You already, if you see in Schneider, Unity Pro or Siemens, if you drag and drop, it will automatically create the timer itself, the timer tag itself. But here no, you have to create the timer name first. Therefore it is showing undefined earlier. See, I already set the timer now to 10,000. This means 10 milliseconds. Like, because you need to first understand the timer, what is the 10,000, because if you go for help you can find very easily. It is millisecond or second or minutes or hour. And once I created here, see when I given in the normally open, it's created automatically the timer, complete timer block. So you can define directly from here. See here, timer dot pre preset accumulate, and also you have lot of other option, timer output and everything. So I will just enter here timer dot en enable, timer enable, and here I am just giving, I am adding the output of that. Once the timer on, the output will automatically on from this side. So what I will do now, I will just add the output. See, there is some local coil like 1.1 2.c 2.1 2.0. This means inputs and this is output. So I added for the hardware tag. See, once I added here, it's become okay. So the data types which I added here, you need to be first understand what is this, because it's predefined one. Local 2.0 out data 0. This means output number 1. This is 2 means OB output number, digital output code, the signal channel number is 0. So you already added this one directly here. And in the next rung, just I created the rung and I add the normally open contact and add again the timer bit here. See here, I will check here. We have many. See, this 2 is double integer. See, now I added double integer. It will show the error continuously. And I will try to add here. See, in this place I will add now counter. Just I will double click. It will add it automatically counter here. Similarly, how you added there, you just see here. Just enter here the right click or enter the tag. Just enter some name, counter 1, and it is undefined. So similarly, how you done before, similarly you need to do here also. Okay, because if you do, it will not work. So you have to create a new counter and define here. Once you create it, it will be automatically added and you can edit your values. See the counter values. Still see in this line the error is still, it is there. This means if we see the where is the problem, you need to be first see, even I can add some counter value and I can add some comparison value as well, like this. So just I need to find what is the problem there. See here, if I click that timer underscore, see enable, it is okay. But if you see from before, it is accumulator, it's not wrong, because the accumulator is double integer. You cannot define the double integer in the normally open contact, correct? So it is there is error before. So now even if you think there is timer enable in upside and downside, you can make one rung as well. In the first rung, one rung itself you can give to the another one. But in my case, I will leave this one, and we will go to now the next operation. Maybe we can go now to the next one called compare. Before that, just I will show you. And now if you see for that timer, you have already timer.enable in both the rung. If you need to think, you can add both rung together. But if you understand how to make the link between these two rungs, example, this is the rung number rung 2 and rung number line 3. So you used, so you can utilize very easily in other places, example in the other programming languages. But here you just need to first understand how to make this link between these timers and the second rung, like rung number 2 and 3 together, because here this is one of the big tasks in Logix Designer. So if you not able to do this, just leave it this current time. So you can do this one once you become expert. So in our current situation, you can use this same rungs, like in separate rungs for rung line number 2 and rung line number 3. So now I will go for rung 4. In this line we are going to use the compare block. So you know already what is compare. You have to compare the value either less than or greater than or equal to. Okay, just example, now you already have counter. So we can utilize this counter here directly, and you can counter, maybe if the counter is greater than or equal to 0, 30 or 20, you can stop some activity or start some activity. So you can do the logic directly here. So see here, from our case I just add the counter COUNT, what I entered here, the counter name, you have to give the same name here. See, I just give counter dot CU and I will give equal to 30. But if you see, still I did not able to, I had already entered, but there will be some error. So I will explain you that one. Before that, just I will add some coil directly. You just click there and add the coil. If I click somewhere, it will be add in some other places. So be careful for that. Just add in the same run, normally open contact, normally open coil. Then right click and add the tag. I am going to create one more tag here called pump underscore just I will add something called pump underscore start underscore ready. So just I will add one tag for temporarily and I will just give create here. See, still the error continues here because I already given the compare value here. See, if you click the place, you can find all the things like element data, usage, data source, data, tag, scope and value. But still there is some error because if you click that one, you can understand you already created the comparison here. No? Counter is equal to 30. See here, if you create, you have to, if you check here, you have to again create the compare, correct? Even if I give something here, I am giving again here and here, it will not work directly. Again I am informing these things. If you see in the other programming languages, if I create something, example, if I drag and drop counter or timer or compare block, it will be automatically defined as well. It will be defined a new counter, new timer and everything. But here I told you, you have to define your counter name, example counter 1, counter 2, counter 3, like this. So similarly you have to create, you have to define the tags and counters before you are starting these things. And other thing, you don't know where is the problem, but you know already there is the red color, it is available. This means there is in the rung there is some issue, but we don't know, maybe you have many rungs have the same issues, but you need to know what is the problem. So you have to validate your application. Once you validated, see, you can find the error. It's mentioned that one error in this rung. So you can find maybe what is the, it will not clearly mention that what is the exact problem. See here, it's mentioned only the program error only. See here, it's mentioned the new logic, it's mentioned only in the place only, like okay, this is the error, but you don't know what is the exact problem. So you need to be find first in your logic. See here, you have the complete rung number 4 comparison block, you have error. It's mentioned already in these things. So you need to be understand what is that exact problem error in this error place. See, you can find here each one. But for warning, no issue for us, only the problem is error. So how I can rectify this error? So if you don't know more about how to rectify, you have to find in the help first. I told you before, if you need to go to the error, you have to find the help first, and after that you can find from the error itself. It is showing that this comparison is invalid expression. So what is that invalid expression? See, now if I click here in the counter, I mention only the counter, but in the counter you have many parameters. Example, counter, preset, accumulator, and CU and D. Okay, and also sometimes it will show you enable and lot of things, parameters. No? So first of all you need to understand that things. Okay, for that you have to go first to the help, and you need to verify, you need to check these things first. See, if you go for help, if you click normally in the help, it will go some general one, and you need to be search in the right side column, and you need to be check where is the, see, compare, and I will open the compare. See here, and you can see how to use this one, and what is the parameters you can use, and what are the expressions you can use. Everything it's mentioned in the line. See here, less than, greater than, or equal to, not equal, everything you can find from this help file. And it's mentioned here, see, value is equal to, value 1 is equal to value 2, like this. So you need to be first understand the each instructions before you are going to implement in your application. So once you understand the instructions, then it is very easy to use in your program. See here, you can find valid operators, and also it's mentioned compare instructions, everything. So see here, you already mentioned here counter is equal to 30. Okay, but you did not mention that this counter means it will, I told you before, it's having the many functions, it's not one value itself. So you need to be first understand the concepts, how you need to be utilize your expression. Once you double click the counter, see, you can find here counter.pre, and also you can find here which is double integer and which is boolean. Before you try to use boolean, so it's coming error. So you need to be first identify what is that exact name. In the example I told you, you need to study the instruction first. See, now there is no error because there is only two in the count, in the comparison, in the counter block you have only PRE and accumulator. These two only you can utilize in your comparison block. You cannot utilize the other functions because others is only the booleans. See, now I already added the preset or accumulate, I cannot get error. So you need to understand first, you have to study your instruction. Okay, once it's okay, see, you cannot find any error, and I compile this application, I don't have any errors, so I can utilize now this application. So this is the first step what we've done for the programming, and we make some, at least some basic programming of how to utilize your ranks, and also the some other functions like timers, counters, compare blocks, everything. So I hope you understand this basic first step of the logic. So we can move to the next step. Before moving to the UDT, first you need to understand what is UDT. UDT means user defined data types. These UDT are commonly used in PLC programming in order to group the data and maximize the code reusability. You have to create the first UDT, like user defined tags first. For the tags you have to use in your logic based on your application. So this is very useful for any of the programmer who is using for the big application. They can use this application, and also there is many other advantages in this UDT. I will explain when we are working in this one. Let's start now. Thus, if you see in the left side, you can find assets. Below the assets, you can find data types and you can find user defined. If you see in the user defined, you have two things. One, you can make a new or you can import from the old application. Now in our case, I am going to create a new data types. So I just added motion underscore UDT. And if once I enter this one, I get some warning or error because you have to use at least one member in this group. So I'm adding one by one now. First I will add motion underscore pump underscore 1. See, after that you have to give the data type. Here you can find all the data type. And I told you before, you can either directly select from this option, okay, and you can give directly, or you can give your data type. Maybe it is more boolean or anything. But I told you before, there is some advantages. I am explaining now. You see here, already they created the motion group, motion instructions, everything at predefined. I can utilize this application. If you click this one, see, they already defined everything for this motion instruction. So I can use directly from my application this one. This is one of the beauty of this UDT, which they created already for most of the applications. If I use for pump 2 as well, just I will give motion pump 2. This is for motion controller. So I can just add here motion underscore instruction. See, once I entered, it will come automatically to browse and it will come directly to your data type. See, just I will add for pump 3 as well, and I can insert here directly the data type. See, you can find here directly, and if you add more, you can add how many you need. And before that, just if you click here, see, you have something called dimension. Even you can give the dimension array. This is called array dimension. So you can give the dimension as well. I can give here, this is for 10 dimension 10, and see, you have almost 3 dimension for some of the applications, some of the data types. For us, it's enabled only for first dimension only. So I can give 10 for each one, and I will add for another pump, motion underscore pump 4. And I will give the data type again the same motion instruction, and I will add dimension called 10, and I will add the last one, motion pump 5. This means I am creating this for 5 pumps at initial stage, but this is again, I did not create any user defined now. I just add from the data source itself, data type itself. Okay, this is first one. Okay, if you have something for the pump which they created earlier in the Rockwell automation, or there is some library itself, you can utilize that one directly. Okay, see here, you can define this everything, and also if you see here, I can export the data type. You can see, now I am going to export in the desktop. See, I will give same name, it will be in the default in the same name, and I just exported. And you can find the location here, exported location in the downside as well. And if you need to minimize, see, you can find the here this UDT file. So this is one easiest step you can follow for some of the applications, some of the places. But in our case, I told you I need to create one application for pump. I will show you here. I will add for one pump complete tags which we created earlier in the controller tags as well as in the parameters and local tags. Similarly, I am going to create here directly in the UDT itself, pump underscore data and it is asking to add some members. So I will add here pump members. First I will add the pump status signals like pump underscore run, and in the data type I can add boolean, and I can add for the second one pump underscore trip. Then I can add the data type boolean again. I will move to the third one pump underscore auto. Then I will give you as well boolean. Then I will go for the next one pump underscore manual as well boolean. Okay, now I can go to command. So I can give you pump underscore start command. This is also, it is boolean, and I will give pump start command. So this all, it is boolean because these are status and commands, and I will give now pump speed control pump underscore speed. So I can give here variable. No? This is either you can give integer or real based on your application. So I will add here real. So this is because this is by percentage pump speed. So I will, this is like analog. So I can add this all. See, now we added everything in one group called pump data. So once I saved, I don't have any error. So I will close this pump data. If I go to the controller tag, see, I cannot find here, but you need to be add this one in your data here. See, I can add here as well pump underscore complete data. This is for complete data, no? So I can give you complete one. See, here I can define the data type. See, we already created a new data type, na? User defined data type. So I can use that one directly. See, once I add it, you can find now all the tags for the pump you can find here directly. Similarly, I can give you pump underscore complete data complete true. This is for second pump. So you don't need to define each time for each pump. So it's already defined in one tag. It's like a one name itself, pump underscore complete one. Similarly, I will give for complete 2. If you have 100 pumps, you can define only pump only here, 100 pump. So it will take directly from your user defined data types. So this is the one I told you before. You need to be create in commonly in one time, and you can utilize this one in many other times. What I will do now, I can add a new program for this. Just I will show you how to use this one. Just add new routine. And I will create a new routine called for UDT test. So I will put the name itself UDT underscore test. Once I added that one, just click UDT test, and here I need to define these tags. So what I will do now for C here, just I will make browse. I will go to the pump complete 1 and 2, any one of them. If I click there, see, you can find the complete list here. Pump underscore run, pump underscore trip, everything. See, it's very easy to make this one. See, and it is very it is like very organized one also if you utilize like this. So whenever you are planning to use for big application, you have more than, like example, 5 or 10 pumps or anything, maybe you have huge IOs, at the time it will minimize your engineering work if you use like this. See, now I just added the pump command as well. So similarly, you can use any of the UDTs tags. You can directly apply in your controller or parameter tags, and you can utilize directly here. So this will be it will reduce your engineering time, as well as it will be organized, and you can utilize this one in future project as well, because you can import and export the complete UDT for and you can use in any of the places. So this is one of the beauty of UDT. So I think you understand how to use these UDT functions here. Similarly, if you add for new run, just you can add here whatever you need. Example for I will add see, I can even you can import and export the rungs as well, and you can utilize directly from this application. This is one way also, and also you can see now how to use the other blocks as well. See, you have a lot of UDT in the application. Just I will show you one now for just for sample. Now we are going to create one more UDT called analog scaling. So I can create a new one called analog scale. Once I open that analog scale, just I need to add the member. Just I will give one name called analog. See here you can utilize any one of the scale, example for any one of the analog instruments, example 11, pressure, flow, or anything. If you need to make a scale, you can use directly from here. Therefore I will give scale, and if you see if I browse, I can find directly the scale. See, I can check here directly, and even if you can define how much array you need. See, you can find here, if I click, you can find here all in input, raw, minimum, maximum, EU, limiting, enable, maximum alarms, everything. So for the scaling, you can find everything that directly. So similarly, the Rockwell automation team, they already created the library for Studio 5000. So you have most of the libraries for pumps, analogs, valves, everything is already created in the application. So you can utilize directly from this library. And in the next section, we can create for analogs, as well as some other, we can see the other features as well. And we will continue with FT view as well. Like later on, we can create in the SCADA application, HMIs, everything. We will check one by one. So I hope you enjoy this video. If you like this video, kindly press the like button, and if you have any comments, kindly comment in the comment section, as well as share to your friends. Thank you.